I want to start today with a little conversation about analog and digital data, because so much of what we do in streaming data involves dealing with data that's being created as analog data, and we need to work with it as digital data. So if you think of voltage, for example, on a wire, and you're monitoring this wire all the time. You want to keep track of this voltage. Well, the voltage on a wire, say it's going from 0 to 10 volts, and it varies over time, may look something like this, right? It's going up and down, up and down, up and down over time. And it's being presented all the time as a voltage. What we want to do is we want to look at it at different points along the way, though. And so what we do is we do what's called sampling. And so I say, if this is, for example, this entire time period here is 10 seconds, I say, well, I'm going to look at this data every 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 data points. This one representing this point. I'm going to change colors here so you can actually see a little bit more about what I'm doing. This second here is representing this data point. This one represents this data point. This one represents here, and so on. And so you get a good sense of what's happening across the wire at these different points in time. If I were to graph this data, you would see it would look pretty much something like what the data is actually doing, if my data actually looks like this. If, however, I say I'm only going to sample this data every half a second, or let's say every 5 seconds, that means I'm going to get a data point here, and I'm going to get a data point here halfway through, and then I'm going to get a data point here. If I graph that, it doesn't look at all like what the data is actually doing. So you can see sampling more of the data, more of the time, actually gives you a truer picture of what is happening along the wire. Now, it isn't free. This sampling comes at a cost. And what is this cost? Well, for the first cost is the data that you're going to be collecting is going to be much larger. If I, for example, store data at every second, I end up with 10 records. So 1 second over 10 seconds equals 10. If, however, I'm sampling it at a much higher rate, let's say I want to sample at 1 millisecond or 1/1000th of a second, I would get a very accurate picture because I'm taking samples so quickly. But I would also have, at 1 millisecond, I would have 10,000 records of data. Now this is where streaming data comes in, and the tools like IBM Streams, in order to store, process, and analyze this data, is they're built around analyzing record sets this large in real time. We're going to talk about that in a future episode. But the idea of sampling is such that you want to sample at a high enough rate that it gives an accurate depiction of what you're trying to monitor, but you also want to sample at a low enough rate that you don't overwhelm your sensor's ability to store the data and to process the data in real time. So we use devices called analog to digital converters, and it just so happens that the Raspberry Pi has some of these things built into it. The device that I'm using to store the electrocardiogram data, for example, has a very fast analog to digital processor that can actually generate data every millisecond and actually process data every millisecond. So I actually have now a program which is generating for every second of EKG data coming off the eHealth sensor. It actually has 1,000 records worth of data that I can process, graph, whatever I want to do with it. So we're going to talk about how we deal with some of this processing a little bit in a different episode, but I just want to give you a brief introduction to sort of analog versus digital data and how it applies to the streaming data world. Thank you.